Welcome to VW 8.1. Today we're going to be discussing inverse trig functions. So to start, let's think about what we've been doing. So on your speed quiz, I give you sine of an angle, and then you write some length. To be more precise, we could say a ratio. So for example, you say like sine pi over 2, that becomes 1, right? That represents some length on the circle. Now the inverse function, what that's going to do is the reverse. It's going to take the length and it's going to return an angle. So to do these, this is what you're going to do. You're going to try use a circle, but you're going to notice a problem arises. Because if I were to draw my xy axis, and let's say I put a circle right here, if I were to ask you where does sine hit root 2 over 2, you would get two answers. That happens at here, pi over 4, and here, 3 pi over 4. The issue is we cannot have two answers because we're talking about functions here. Right, so the key word here is functions. Now for functions, you should recall from algebra that a function only has one answer. Every input creates only one output, which means this is an issue, right? We can't have these two answers. So the way we do that is we actually restrict the answers. So for sine, what happens is we actually don't consider quadrants 2 and 3 here. We don't even want that. For sine, what you do is you only highlight quadrants 1 and 4. And we'll talk more of the theory about this for the y in class. But for now, we're going to focus on mechanics. So you highlight quadrants 1 and 4, and within that, you think about where does sine hit root 2 over 2. And now, notice how that's only one place. That would be pi over 4, and that is your only answer. So a little shortcut you're going to write is right here, range of inverse functions. We're going to write sine right there. That's going to be our little cheat sheet. So do a couple examples here. Negative 1/2. So sine inverse of negative 1/2. We're going to highlight quadrants 1 and 4. Negative 1/2. That's a little below the 0 mark. That's right there. Now a lot of people want to write 330 degrees here. However, that is incorrect. The reason that does not work is because to get to 330, you need to rotate like this. And notice how we're leaving the range. We're leaving the blue line. So that is actually not going to work. The only way we get to that line, at least purple, is you simply go down. So that answer would be negative 30 or negative pi over 6. That is the true answer. So following the same process, let's highlight quadrants 1 and 4. We know that's negative root 2 over 2 would happen down here. The answer is negative 45 degrees. And I'm using both, so actually I'll put or negative pi over 4. If it doesn't specify, you could use either radians or degrees. I'm fine with either. All right, so there it is. There's sine inverse. Let's go to cosine inverse. So cosine inverse, if we just think about it logically, sine inverse, use 1 and 4 because it very nicely fit, because if you think about quadrants 1 and 4 here, it covers all possible y values, positive and negative. So for cosine, if you follow that same logic, we're going to use quadrants 1 and 2. So notice how that covers every possible x value. So there's our red line right there, 1 and 2. Let's highlight where negative root 3 over 2 would happen. That's right here. That answer is 5 pi over 6, or 150 degrees. So our cheat sheet, we can add to it now. Sine, watch this, CO, cosine. Fits really well. Let's try an example, one more. We're going to highlight quadrants 1 and 2. Negative 1/2 is right here. Answer is 2 pi over 3, or 120 degrees. Here's our last example. We're going to do tan inverse of root 3. So let's put our xy axis here. Now for tan, what's interesting is quadrants 1 and 2 actually would cover all positive and negative values of tan. However, it actually uses quadrants 1 and 4. Now the reason for that is because if you do that, tangent of 0 is 0 right here. But tangent of 90 is undefined, and you don't really want to cross undefined up there. So to make it easier, we'll just use 1 and 4. And again, I can explain more of the theory behind that tomorrow when we talk about this in class. But here's 1 and 4. We're going to put the tick mark where root 3 happens. That's right there. Answer, pi over 3 or 60 degrees. So to complete everything, we'll write sine, cosine goes 1 and 2, and look at that, tan goes to 1 and 4, and a lot of people highlight this cost right here. That's a great way to remember it. So here's our last example for this part. For tan, we highlight quadrants 1 and 4. Negative 1's going to be in quadrant 4. And again, do not write 315 degrees. That does not work because you break the plane. If you were to use 315, you're going to go around that way, which is not okay. You simply just go down. So the answer is negative 45 or negative pi over 4. For this next part of the lesson, we're going to be talking about composite functions. So you might recall this word composite from Algebra 2b. Composite is just referring to a function in a function, like f of f or f of g. So essentially, we're going to be putting a function within a function. So before we do it, let's quickly go over the ranges. So hopefully you recall cosine is 1 and 2, sine is 1 and 4, tan is 1 and 4. You have to have that internalized before you can do any of these problems. So let's go to this first one. Find the exact value of each of the following composite functions. Sine inverse of sine of pi over 8. So your intuition is probably going to tell you just cross this out and write pi over 8. While for this one, that is coincidentally the answer, that is not the way to do it. So make sure you do not just do that. It takes a little bit more work. For these, I actually call these, you can put a big star here, I call them circle problems. Because what we're going to do is use a circle to figure this out. And a big characteristic of circle problems is you have this inverse on the outside, meaning your answer is going to be an angle. Now the technique, again, it's called circle problems because we're going to use a circle. Here's our xy axis. Let's highlight quadrants 1 and 4 because look at that sine inverse. So highlight quadrants 1 and 4. And what you're going to do is focus on this pi over 8 and estimate where that would be. So I can say that somewhere in quadrant 1. Right there. Now the way these problems work is that if you're in the range, so if this pi over 8 is within this red line, then you're good. That means you can cancel it and your answer is done. So again, we can see that we are in with this range here. So this does work. That means these cancel and the answer actually is pi over 8. So your next question would logically be, so what happens if it's not in the range? So let's look at B. So again, highlight quadrants 1 and 4. 5 pi over 8, that should be somewhere in quadrant 2. That'd be right here. Now the reason I know that is because this should be 4 pi over 8. That's pi over 2. So now we're in a situation where we can see we are not in the range. So what you do is you use reflection to get it in the range. And the way you use reflection is look at this function here. We're talking about sine, which means we have to reflect it so that the y value won't change. So reflect so y doesn't change, which means we simply have to reflect over the y-axis. So watch what happens. We reflect this angle right there. Now we are within the range. Now what you need to do is a little geometry. That's 5 pi over 8. If you reflect it, this new angle, you can do a bunch of geometry tricks, but you get 3 pi over 8. Some people just think of it as, well, this is 4 and that's 5, and That should be 3 because it's 1 away. And that means you can rewrite the question as this: sine inverse of sine of 3 pi over 8, because that is the exact same value. And now that we are within the range of sine inverse, we can simply cross them out. And that becomes 3 pi over 8. So again, the whole point of these is to get within the range. So in case that wasn't clear, I know these are always a little more challenging. I'm going to shrink this, and I'm going to give you one more problem so you can see it work. I'll do one right here. Sine inverse of sine of 7 pi over 6. So I'll do the shorthand method now. So we highlight quadrants 1 and 4. I can see 7 pi over 6 is right here. That's clearly out of the range. So we're going to reflect it right there over the y-axis. And now here's the tricky part. Again, we're going down, so that should be negative pi over 6, which means that's your answer. So if you want to be precise, you can rewrite it as this. Or some people just circle that, and that would be fine too. I'll take either one. Okay, so those are called circle problems. So make sure you guys highlight that. Circle problems. These next ones, notice how they're very similar, except highlight where the inverse is located now. They're located on the inside. So see earlier they're on the outside. These are on the inside. So in that situation, what you do is you call these triangle problems. Meaning we're going to draw a triangle. So what's really neat about these is that if I write sine inverse of 0.5, you have to understand that this piece right here, this is an angle. So you can actually just call that theta. And the reason I'm bringing that up is because we're actually going to approach this the exact same way as before. Here's our axis. We're going to draw a triangle. We can only use quadrants 1 and 4 because it's sine inverse. Now notice how this is positive. So what you're going to do is you're going to draw a triangle in quadrant 1. And if it's 1/2, think of this as opposite over hypotenuse. That's 1 over 2. This is root 3. And then right here we can write theta. So what I just did is I'm saying this piece right here, sine inverse of 0.5, that is directly related to this triangle here. That highlighted piece is this angle right here. That is the exact same angle. It's just in triangle form now. So the whole question transforms to this. Sine of theta, look at your triangle. That would be O over H. That's 1/2. Now you're probably thinking, why go through all that trouble if they simply cancel out? And you're right, in most cases, this in triangle problems, they do cancel out in this one. However, the concept is super important, because if you look at B, if you just mindlessly cancel the bottom right 1.8, that would be wrong. So let me show you exactly what I mean. Let's highlight quadrants 1 and 4 again. I'm going to draw my triangle. There's theta. 1.8, so make it easier, I'll just put 1.8 and 1. If you look at this triangle, you should recognize that this triangle is impossible. And that's because your hypotenuse right here is shorter than the leg. That can never happen, which means this is no solution. This cannot happen. So that's why for these, you never just want to mindlessly cancel out. You always got to think about what's actually happening. So now let's do a couple more. Let's do cosine. So luckily, these are all pretty similar. You all start the same way. So to start, I'm just going to copy and paste these. Now what you have to be able to do in all of these is identify, is it a circle problem or is it a triangle problem? And the best way to do that is to look at where the inverse is located. So inverse is here, so it's outside, inside, outside, inside. So I want you to think, if it's on the outside, that's a circle problem. Inside, triangle. Outside, circle. Inside, triangle. That's going to help you create a framework for what you have to do. So let's do the circle ones first. So if it's a circle problem, that means we're going to highlight the range, and actually that's true for triangles as well. But circle problem, we just think about it more circular. We're going to highlight pi over 12. So pi over 12 on our circle, that would be right there, somewhere in quadrant 1. Notice how we are in the range. So I'll write that. We are in the range. And if you're in the range, you're good. Just cancel it out. Pi over 12 is the answer. So that was a great problem. Next one, let's highlight 1 and 2 here. Negative 2 pi over 3, so that would be, if you rotate negative, that would be down here. So we can clearly see we are not in the range. So let's use reflection. And because it's cosine, we know we're dealing with the x value. So for this one, we're going to reflect over the x-axis. And look how nicely that works, because now we're right in the range there. So what's our new angle? That's positive 2 pi over 3. So 2 pi over 3 is your new answer. Done. Okay, let's do the triangle ones. We're going to highlight same thing, 1 and 2. Now notice how this is negative 0.4. That's important because that means your triangle is going to be in the negative region. So your triangle is going to be somewhere here. So to make it easy, I'm just going to put negative 0.4 and 1. You could use 4 and 10 or 2 and 5, but I think it's easier just to do this. And I'm now going to find the opposite leg, because look, we want cosine of this. And if you think about the picture, that's theta. We want cosine of theta, and that's just the same number that was given. Done. Now if you look at this next one, don't be freaked out by the pi. You have to stick with what we've been doing. We highlight 1 and 2. Now we're going to put a triangle in quadrant 1 because pi is positive. And think of this as pi over 1. So that's pi and that's 1. So it's very important to understand that that is not an angle. Not an angle. Pi is just a number. So from here, that should be enough information, right? We know pi is about 3.14. So hopefully you're realizing this is impossible. This is no solution. And there we have it. Let's do the last two. So tan, hopefully now you can recognize the inverse is on the outside. That's a circle problem. We're going to highlight quadrants 1 and 4. And 5 pi over 6, that's right below, or right above the x-axis in quadrant 2. So this one we can quickly see we are not in the range. Now for tangent, tangent is the trickiest one. You have to reflect through the origin. Or some people say both x and y, but I think origin is easier. And you do that because for tangent, that's the only way you can reflect while keeping the tan values identical. So if you recall tangent, tangent is positive in quadrants 1 and 3, while it's negative in quadrants 2 and 4. So that way, if you reflect through the origin, you'll maintain the values. So let's reflect that straight through right there. And if you think about it, you get a little bit of geometry. This is pi, which means that little bitty piece there is pi over 6, and these are equal. So that angle must also be pi over 6. And because we're going down, notice how it's down, that'd be negative pi over 6. So if I want to rewrite everything to show my work, you just rewrite this to that. Now we cancel, and there's our answer. Now the last one, notice where the inverse is located. That makes it a triangle problem. Draw a triangle quadrant 1. And I should have highlighted 1 and 4, so I'll do that right now. 1,000 is interesting because that would mean the opposite is 1,000. And the adjacent is 1 if we think of it as 1,000 over 1. And now we have it. Tan of theta is 1,000. So you might have noticed that triangle problems for tan are the best because no matter what, they cancel out because it'll never give you a hypotenuse value. There's no h value given. So for tangent problems, those are going to be the easiest because those are really no thinking. You can just cross it out and you're good. All right, so good luck on the rest of the questions. I'll see you in class.